everyone, I'm Stephanie the Science Gal. Have you been sick lately? If so, you might be on something called Amoxicillin. Have you ever wondered what Amoxicillin is? Well, today we're going to dive into the structure and properties of this drug. Let's have a fireside chat about the history of Amoxicillin. In the 1960s, researchers had an objective to identify a broad-spectrum penicillin. This led to the synthesis of amoxicillin in 1970. Amoxicillin is very closely related to ampicillin, but is better absorbed when given orally. So, in 1981, researchers made this into tablet form and launched it in the UK. In 2007, they are still developing very high-dose regimens, which means that it is still an important role in the treatment of many community-acquired infections.
Hey guys, it's Nancy. So what's amoxicillin for? Well, you can use it for bacterial infections, for the nose, ear, throat, and skin. It can also be used on pneumonia, tonsillitis, and bronchitis. It's a type of inhibitor that stops the bacterial wall from forming, which leads to bacterial death. It comes in capsules, tablets, and powder form. Some side effects can include headache, stomach pain, nausea, vomiting, and diarrhea, itchy or swollen tongue. Thanks for listening.
Hey, Chemist Morgan, what did dipoles say in passing?
I don't know, Stephanie.
Hey, have you got a moment?
Hi, I'm Chemist Maggie, and I'm going to teach you about how amoxicillin works in the body. So here we have a bacteria, and zooming into the cell wall of the bacteria, inside we have these peptidoglycan cross-linkages, which give it its rigidity and strength. And also we have penicillin binding proteins. So what happens is amoxicillin comes in and binds to these PVPs, which causes the cross linkages to break. And the cell wall loses its strength and rigidity, which then causes the cell to lyse.
Why do chemists say that you shouldn't drink water while you're studying?
Why?
Because it reduces your concentration.
Hi, I'm Chemist Maddie, and I'm going to tell you some of the basic things about amoxicillin. So here we can see that the chemical formula is 16 carbons, 19 hydrogens, 3 nitrogens, 5 oxygens, and 1 sulfur. And this is what it looks like on a 2D form. And here is the 3D molecular structure. So amoxicillin is a part of the penicillin class, and it has a melting point of 194 degrees Celsius. It is water soluble, and it also has 2 different sites for pK values. There's a 3.2 site for like more of the acidic sites, and an 11.7, which is more of like the amine sites.
Did you hear that oxygen and potassium went on a date last night?
I did. How'd it go?
It went okay. Hello, I'm Chemist Morgan, and I'm going to teach you how to make amoxicillin. The mechanism for this reaction is a simple acyl transfer where we convert this ester into this amide. So in the first step of the reaction, these electrons from nitrogen attack the carbonyl, forming your tetrahedral intermediate over here. In step number 2, the tetrahedral intermediate collapses to form this molecule. And then our methoxy that we created in the last step deprotonates the nitrogen, forming your final product, amoxicillin.
Hey, Chemist Morgan, you want to hear a fun joke?
Sure.
2 chemists go into a bar. The first one says, I think I'll have H2O. And the other one says, I think I'll have H2O too. But then he died.
Oh, that's sad.